last meeting, we ended up with this activity, no? And we now proceed with our next topic, translation of liquid masses for moving vessels, no? So in here, liquid masses, no, is transported, no, from one place to the other, no? And let's say we have this uh, a tank filled with liquid, no? And in this case, this tank that is filled with liquid is at rest. So it's not accelerating, no? And if it is not accelerating, it is said to be in equilibrium, no? Now, consider another tank wherein it accelerates, where the acceleration given is not equal to zero. So, and it proceeds in this direction. So if it proceeds in this direction, okay, the tendency of the liquid will it will it will resist the motion. No, it is in opposite direction to the motion uh, that is present. Now the motion is towards the right. So as you notice here, the liquid tends to move to the left, right? Liquid tends to move to the left. Now, considering the motion of the body now to the right, so the tendency is that the liquid tends to move to the left. Okay, so there is um a phenomenon that we can consider, and that phenomenon is due to the reverse effective force or the fictitious inertia force no, that is present in the liquid due to its motion. No? So, in this case, no, so bago ko ipaliwanag in detail, napansin nyo ba pagka halimbawa, umabante yung, kung kayo ay, let's say, sumakay ng jeep, tapos, biglang umabante yung jeep, napapansin nyo, in opposite direction ng motion, pagka bigla niyang in-accelerate, yung, ano nyo, yung motion nyo, no, in opposite direction. Okay, ganun din sa tubig, no? Ay, sa liquid, no? Okay, in opposite direction. Okay, dun sa direction of acceleration, no? So, in this case, let's consider a particle, no? A particle of the liquid. And let's say this point is the particle of liquid. And considering that point, we consider all the forces acting on it. First, that particle has weight. Okay, it has weight. Next, the particle is on top of the other particles of the liquid. Since it is on top, that particle below this particle exerts a force, no, which is directed normal to this surface, no. When I talk about normal, when I say normal, it is perpendicular, no? Perpendicular direction of the force applied to the surface. So this is 90 degrees. Okay? That was taught to you in physics 1, right? So recall your physics 1, normal force. The norm we can only say that the force is normal if the direction of the force is perpendicular to the surface. Now, so this liquid surface is now considered. Now, So a particle exerts a force on the other particle. So this is being exerted on this particle of interest. So in that case, we project there, and it is now 90 degrees with respect to the surface, no? To the liquid surface. So this is our normal force, no? And also, another thing to consider is the reverse effective force. As I have told a while ago, bakit tendency ng liquid kumaliwa kung ang direction ng acceleration ay kanan? Nag-accelerate, no? Dahil sa property na tinatawag na inertia, no? So, in that case, we have the reverse effective force or the fictitious inertia force, no? W equals to the weight of the liquid particle and is the normal force acting on the liquid particle. REF is the reverse effective force or we call as fictitious inertia force. Okay? Pag sinabi natin fictitious, meaning it is believed to exist, no? They hypothesized na nag-exist itong force na to, no? Siyempre may batayan yan ng kanilang yung mga nag-discover niyan, meron silang batayan uh, kung bakit nag-arrive sila sa ganitong concept, no? Reverse effective force. So, kung ito yung direction of acceleration, okay, it's natural for the object or any matter, no, to be in opposite direction to the acceleration, no, in opposite direction to the acceleration. So tendency niya, no, most of the liquid will be uh, on the left side, no, because or the direction is on the right, no. Kung solid object yan, kung bigla mong inabante yan, no, iting acceleration tendency, kakaliwa siya yung kanyang motion, no? Kakaliwa, no? So, kaya lang, liquid yan eh, no? So, that means, ganyan yung magiging outcome. Hindi siya solid eh, liquid kasi yan, no? Kaya, meron pa rin matitira dito. Pero na lang, kung super bilis, kung super nag-accelerate masyado, tendency na baka mawala yung tubig doon, no? Depende. O liquid, any liquid. Hindi lang tubig, no? Okay, so considering that, no? We consider this part. Okay, consider this part. We are interested finding this angle. No? What is that angle? So let's consider the diagram. So this part, no, this horizontal line is considered. Another line to consider is this line where the normal force is directed, no, or is parallel with, no, normal force is in parallel with this line. So that makes it 90 degrees with respect to the surface, no. And also the angle. Let's consider the angle between the liquid surface and this horizontal line, which is parallel to the ground. So this is our ground parallel to it, no? And this is angle theta. So this is now angle theta. Now, let's form another line, horizontal line, wherein that line passes through this particle. Okay? They are particle of concern. So, in that case, I have already taught you about alternating angles before, no? Since the two are alternating angles, They are the same now in magnitude. No? Diba? Kapag meron kang dalawang parallel line, okay, dalawang parallel line, tapos may transversal, no? Pag sinabi nating transversal, ito yung line na nag-intersect sa dalawang parallel lines. And yung angle na to ay kapareho dito. Ang tawag dyan ay alternating angles, no? So, alternating angles. And alternating angles are equal in measurement. No? They are congruent. No? So, these are alternating angles now. No? And since this line, let's say line 1, and we have the surface, no? The angle is 90 degrees, right? Between line 1 and the surface. So, in this case, if this is theta, so this will be 90 degrees minus theta. Because the sum must be 90 degrees. No? So that will be 90 degrees minus theta. Okay? So the sum of the two is 90 degrees. And we consider also this angle. Let's say line 2 and line 3. What can we say about line 2 and line 3? They are perpendicular, right? And if they are perpendicular, the angle between them is 90 degrees as well. If that's the case, if this is 90 degrees minus theta, this will be theta. No? So that is now the outcome. So that will be theta. Alright? And that gives us our angle of concern. So this is now theta. So which is our interest. No? Our concern is this angle, which is the same as the angle here. No? So the angle of inclination, no? It is inclined, right? So that is considered. Now, considering this situation, no? Now, if this acceleration is constant, let's say it is constant. If the acceleration is constant, this will be the fixed motion or fixed, not motion, fixed. Okay, what you can see in the picture now in the diagram will be fixed. So meaning there's no movement of the liquid. No, it is static. No, so there's no movement of the liquid if the acceleration remains constant. Therefore, we can say that the liquid is in equilibrium because there's no motion involved. Although it's moving, okay, but the liquid inside remains the same. It does not move anymore because the acceleration is constant. So it will be in this it will look like this. No? It will look like this, and for as long that there is acceleration that is constant, it will look like this. No? But when it becomes zero, so there will come a point that it will be like this. No? So this is stagnant. No? Well, if the acceleration remain constant, this will also be stagnant, wherein at the left side, it has a higher elevation compared to the right side. No? So case-to-case basis. No? So this is an equilibrium condition. No? Considering this situation, this is an equilibrium condition. For as long as the acceleration is constant. So for an acceleration that is constant, it is in equilibrium condition. Okay? And if it is in equilibrium condition, so summation of all forces is zero. No? Summation of all forces is equals to zero. So we can apply Newton's first law. No? And since we can apply Newton's first law, if we add all of these forces, W plus N plus REF, so that will be zero. So we can connect from the tail of the other to the head of the other vector. Let's say we consider the weight. Now, next we consider the reverse effective force. We connect the tail of the reverse effective force to the head of the weight, no? To the arrowhead of the weight. So this is the weight of the reverse effective force now. Connecting the tail of the reverse effective force to the arrowhead of the weight. Likewise, we connect the tail of the normal force, no, to the reverse effective force arrowhead. So connecting, we have that, no? So we have that. So this is our normal force. Okay? So the tail of the normal force is connected to the head of the reverse effective force. Okay? This is now what we call as force triangle because there are only three forces involved, no? So that they form a triangle. And in that case, since this is the origin, meaning W, REF, then the normal force, so meaning their sum is zero because it went to the origin, no? The resultant. So the resultant force now is zero. Okay? Nagmula siya sa origin. Tapos, not na terminate siya sa origin. Okay? So kung ganon, summation of all forces is zero. Okay? So lesson yan sa Physics 1. So this is the angle theta. Okay? So this is the angle theta. And if that's the case, this is also theta. Itong dalawa, theta din to. Bakit? Alternating angles sila eh. No? Alternating angles are equal. No? So, they are alternating angles. Okay? Basta merong dalawang parallel line, tapos merong transversal. Okay? So, sabihin niyan, itong angle na to ay equal dito. Alternating angles kasi sila. No? Okay? So, that's a lesson in geometry. And pwede nating kunin yung tangent of theta. Okay, so katawa. So, tangent ang ating concern. Tangent is opposite over adjacent. So, ito yung opposite, ito yung adjacent. So, ito yung theta, opposite niya ay REF. Adjacent niya ay weight. No? Okay? Okay, and then the reverse effective force is equal to the mass times the acceleration. No? So the reverse effective force equals to the mass times the acceleration. Alright? So it has something to do with Newton's second law of motion, the law of acceleration. No? So in here, the body accelerates. So therefore, there is now force developed because it is accelerating. And that force, no, uh, has something to do with the reverse effective force. No? Dahil sa acceleration nito, nagkaroon ng force at yung force na yon, okay, naapektuhan yung liquid level. No? So, naging ganito yung kanyang form. At anong responsible doon? Yung reverse effective force. Okay? Dahil sa reverse effective force, okay, na may kinalaman sa force due to Newton's second law, okay, naging ganito yung outcome, no? Alright, so likewise, the weight is equals to the mass times the acceleration due to gravity, no? And then tangent theta, so ano yung reverse effective force? MA. MA. Ano yung ating weight? mg. So cancel ang mass, so A over G yung ating formula. So yan ang kanilang relationship, no? So yung angle na to, okay, ay equals sa ratio ng A to G, no? So ano yung G? Acceleration due to gravity. So that is 9.81 meter per second squared o kaya 32.2 feet per second squared. No? Tapos yung A, yung ating linear acceleration. No? Linear acceleration. So note that REF is acting in opposite direction with A. No? So kung ito yung direction ng acceleration to the right, yung REF natin to the left. No? So consider naman natin yung inclined na surface. No? Solid surface na inclined. At nandito yung ating tank. At yung tank na yan, yung level ng liquid, kapareho ng level ng ground, di ba? Siyempre, mag-a-adjust yung liquid, di ba? Hindi naman siya ganyan pa rin. Ganyan pa rin ba? Hindi, mag-a-adjust siya, siyempre. No? So, dahil liquid siya. So, na kung saan kapareho ng level ng ground. No? Okay? So, these are parallel. No? Ito, parallel dito. Okay? So, that's the initial. So, ibig sabihin, stagnant pa yan, ha? Stagnant. So, not moving. Liquid not moving. No? So, wherein, it is at rest. No acceleration. No? Ngayon, consider naman natin this situation wherein it is accelerating to the right. Okay? So, dahil nag-accelerate to the right, merong reverse effective force na nagdulot na mas maraming tubig na nasa left kumpara sa nasa right. So, ibig sabihin, umakyat yung level doon sa left, bumaba yung level sa right dahil na-accelerate, no? Okay? So, that is now the outcome, no? Alright, so next, let's consider a particle of what? Of the liquid. And that liquid particle, we consider the weight of that particle, then the normal force, no, which is perpendicular to the surface, no. And iting acceleration natin, take note. Yung acceleration natin naka-incline, no? Inclined acceleration. So, hindi siya horizontal, no? Inclined siya. So, it has two components now. Yung horizontal component niya, AH, no? At yung kanyang vertical component, AV. Okay? So, meron siyang two components. Okay? Horizontal and vertical. So, kasi ito siya naka-incline. So, meron siyang horizontal component and vertical component. Di gaya ng dati, kapareho lang siya ng A horizontal. So, ang AV natin ay 0. Kapag yung kaninang pinakita ko na horizontal lang siya. So, in this case, inclined yung ating acceleration. It has two components. And consider natin itong inclination, angle beta. Okay, sabi natin angle beta. It is inclined at an angle beta. No? At therefore, kagaya lang siya ng inclination, beta din ito. No? It follows kasi parallel sila No? Parallel. So, ano sila? Corresponding angles ang tawag dyan. Corresponding angles. No? So, yung angle between A and AH, kapareho ng sa surface na to. No? Yung surface na dalawa. Okay? So, beta din yan. Alright? So, we can now proceed. Take note. So katawa tayo. Okay. So, ang AH, basta given yung acceleration at saka yung beta. So, hypotenuse, A, and beta angle, no? Kasi ganyan yan. They form a right triangle. Ito yung A, AH, AV. They form a right triangle. At ito yung beta natin. So, ang ating AH ay A malapit sa beta, cosine. A cosine beta. AV malayo sa beta, sine. So, A sine beta. Okay. Next, let's consider the reverse effective force. It has now two components. Meron kang reverse effective force horizontal. Ito ang direction ng acceleration natin, horizontal. So, therefore, ang reverse effective force direction ay opposite ng direction of the horizontal component. So, ito yung ating reverse effective force, horizontal. Okay? So, yun siya. Kabaliktaran, doon sa direction ng acceleration. Laging ganon, no? And then, consider natin itong part na to para sa angle dito. Ano kaya yung angle dyan? So, before kunin natin yung angle, another to consider, kung may horizontal component, may vertical component. Kasi meron tayong AV. Therefore, reverse effective force, pailalim. No? So, that is now the direction of the reverse effective force. So, in short, kung ito yung direction ng motion, may puwersang tinutulak yung tubig pakaliwa, may puwersa ring pinipress, kino-compress yung tubig, no? Kino-compress yung tubig. Okay? Yun ang vertical component, yun yung horizontal component, pakaliwa at pailalim para siyang kino-compress, no? Yung force na kino-compress. Okay, so we can proceed. Next, consider natin tong part na to. This is angle theta. Okay, take note itong line na to, parallel dito. Let's say line 1, ito yung line 2. Line 1 is parallel to line 2. Take note, no? So, parallel dyan. So, ito ngayon yung angle natin na i-consider. At ito yung line na kung saan yung theta na to ay kapareho dito dahil alternating angles sila. Okay? Next, consider natin yon. At yung angle na to ay, kung ito ay theta, 90 degrees minus theta para maging 90 degrees. No? Next, yung angle na yon, theta din, para maging 90 degrees. Itong, let's say, line 3 and line 2. No? Line 2 and line 3. Okay? So, therefore, ito ay theta. Kung yun ay theta, ito ay theta. No? Yan. So, again, basta ang ating acceleration ay constant. Okay? Yung liquid na to, magiging stagnant. No? It will become stagnant. So, isabihin, fixed in place. So, basta ang acceleration ay constant. No? So, with that, it is an equilibrium condition. At meron tayong apat na forces to consider. No? I-connect natin yung head ng isa doon sa tail ng isa. No? So hanggang sa umabot tayo sa resultant. At anong in-expect nating resultant? 0. Dahil in equilibrium condition. So ito yung ating weight. Then meron tayong reverse effective force. Kinonect lang natin yung tail ng reverse effective force, vertical, dun sa head ng weight. Then i-connect natin yung tail ng reverse effective force horizontal doon sa head ng reverse effective force vertical. Okay? Then, i-connect natin yung tail ng normal force sa head ng reverse effective force horizontal. Okay? At take note, itong angle na to, theta. Therefore, ito rin ay theta. No? Alternating angles kasi sila. And then, tangent theta, opposite. Ito, opposite. Over adjacent. Ito yung adjacent. No? Pag adjacent, yung malapit dun sa angle. No? So, opposite over adjacent. Weight plus REFV. Okay, so tangent theta equals to MAH over MG plus MAB. No? So, in that case, ayan, reverse effective force horizontal, mass times acceleration, horizontal component, No? Di ba? Tinuro ko yung REF ay equals sa NA. Therefore, kung yung horizontal component, ang co-consider natin, that is MAH. No? Ganun din naman sa vertical, MAV. Weight natin ay mg. Okay? So, pinapakita ko yung derivation, no? Para in case na makalimutan nyo yung formula, at least alam nyo paano i-derive. Okay? Kapag na-develop nyo yung skill na ganito, pagka meron kayong research, let's say yung research nyo may kinalaman sa pag-come up ng formula, o magagamit nyo yung ganitong skill, yung derivation. No? Pagka ang goal nyo ay makapag-formulate ng formula sa ganitong topic. No? Depende kasi sa research goal nyo no? Pagdating sa thesis. So, in this case, tangent theta is equals to, cancel yung mass, so AH over G plus AB. No? So, yan yung ating formula for the angle, tangent of the angle theta. No? Horizontal component of the acceleration over the sum of acceleration due to gravity and the vertical component of the acceleration. So, this is for upward motion. No? This is for upward motion. Pagka paakyat, iba kapag pababa. Pag pababa yan, no, parang ang dating gumagaan yung liquid na to, gumagaan. No? So, sabihin, natutulak pa in opposite direction, natutulak doon. So, sabihin niyan, parang gumagaan. No? Okay, tapos, imbis na i-compress yung opposite, parang umaakyat. Parang umaakyat. Yun ang opposite. No? Pagka opposite direction. So, in this case, hindi ko na i-derive yon. Basta mag-a-arrive ka sa minus. I-derive nyo na lang kung interested kayo. No? Na ma-obtain yung formula na to. Tangent theta equals AH over G minus AV. No? So, this is for downward motion. No? For upward motion, yung aking example na to, for downward motion, it's up to you to derive kung gusto nyo. Okay? Mag-arrive kayo sa formula na to. Okay? So, let's apply the topics I have presented. So, we have the first problem. A rectangular tank, 20 feet long and 6 feet deep and 7 feet width contains 3 feet of water. If the linear acceleration horizontally in the direction of the tank's length is 8.05 feet per second squared, compute the total force due to the water acting on each end of the tank. B. Show that the difference between those forces equals the unbalanced force necessary to accelerate the liquid mass. No? So, given, ito yung ating rectangular tank, 20 feet long, ayan. 6 feet deep, sabi niya. Ayan, 6 feet deep. Then 7 feet width, ayan. Contains 3 feet of water. So, ayan ang ating tank. Rectangular tank yan. It contains 3 feet of water. Ayan. Okay. If the linear acceleration horizontally in the direction of the tank's length is 8.05 feet per second squared. So, ito, no acceleration pa yan. Okay, no acceleration apply. No linear acceleration. Ngayon, punta tayo nung na-accelerate na siya. So, kapag dito, no acceleration. Kapag na-accelerate yan, in the direction of the tank's length, no? Parallel sa 20 feet na length. 8.05 daw eh. Mabilis yan. 8.05 feet per second squared. Take note, constant yan ha. Constant acceleration. Okay? So, yan ay constant acceleration. So, if that's the case, if it is constant, ating outcome, ayan. So, sabihin niya, ito yung direction ng acceleration, ito yung direction ng reverse effective force. Dahil sa reverse effective force, bumaba yung level ng tubig dito, bumaba yung level, tumaas yung level ng tubig sa kaliwa. Okay? So that is the effect, no, due to the reverse effective force or the fictitious inertia force. So, next. O yan. Ito yung condition. Tumaas yung level sa kaliwa, bumaba yung level sa kanan. Ito yung original level, 3 feet. 3 feet yung height, yung depth ng water. Front view natin. Ito siya. So, yan ang front view niya. Okay. 20 feet. So, therefore, meron kang force. Compute the total force due to the water acting on each end of the tank. So, there is now hydrostatic force exerted on the left side of the tank. And on the right side, another hydrostatic force. Okay? So, the hydrostatic force at the left side is simply equal to the specific weight of water, wherein water is assumed at 4 degrees Celsius, multiplied by the centroid HC, no? Yung centroid HC, okay, yung area. So, kasi meron yung projected area, naturo ko na yun before. Okay, for the left part, no, centroid ng left part na area, multiplied by area at the left part, yung area na mapoproject, no? So, ito yung ating HL, height of the liquid at the left part, no? At take note, this is 62.4 pounds per cubic feet. Ito. Bakit 62.4 hindi 9.81 yung ginamit ko? Kasi naka-fit eh. Naka-fit yung mga given. Okay? So, therefore, akmang gamitin yung 62.4. And then, HL over 2. So, yung centroid nung area ay kalahati lang ng HL. Kasi rectangle yan eh. Rectangle. So, meron siyang third dimension. No? Rectangle. Ito yung 7 feet. Diba? So, rectangle. So, kalahati lang ng HL. And then, area, AL. Yung AL mo, yung rectangle na to, no? Yung rectangle dito, no? Na 7 feet din yan, no? So, 7 HL. No? HL times yung third dimension na 7. HL times 7. So, yun ang ating area at the left. So, next, let's consider the this part. Okay. This is angle theta. Okay, yung theta na yan we consider also this is the level of original level of water, di ba? Yun yung original. So, since parallel ito dito, therefore kung theta yan, theta ito. Dahil alternating angles sila, no? So this is now theta. And ano naman yun dito? Okay? Ang tawag dito corresponding angles. Yan. Corresponding angles. Kung theta yun, theta yun. So kung meron kang line, saan yung corresponding angles dyan? Ito, theta, theta. No? Tawag dyan, corresponding angles. Okay? Alpha, alpha. Okay? O ano naman tawag dito sa dalawa na to? Tawag dyan, vertical angles. Lesson yan sa geometry. No? Vertical angles are also equal in measurement. No? Okay, so that is theta. No? O, take note. Consider natin itong part na to. Okay? Ito yon. So, if we consider that part, yung theta, ito ay, sabihin natin, ito ay y, yung height na yan ay y. No? Okay? At take note, ito yung point of intersection. If this is 3 feet, okay, at it's obvious na gitna siya, okay, therefore, mahati, this is now 20 over 2 feet, no? Kalahati, okay, so that is now 20 feet over 2 or 10 feet. So tangent theta is opposite over adjacent. So recall also that tangent theta na na-derive natin ay A over G. Okay, so tangent theta is y over 20 over 2 equals to A over G. So ang y natin ay 20 over 2 multiplied by A, 8.05 feet per second squared over G, 32.2 feet per second squared. So magiging unit niyan ay feet. 2.5 feet. So, HL, ito yung nahanap natin. Ano yung HL? 3 plus Y. Ito ay original level, 3 feet. Tapos ito ay Y. 3 plus Y, 3 feet plus Y, ayun yung HL na hinahanap natin. No? So, that is 5.5 feet. So, therefore, that is 62.4 multiplied by HL, 5.5 over 2 times 7 times 5.5. So, analyze natin. Pounds per cubic feet. Pounds per cubic feet. Ano nung unit nito? Feet. Unit nito, tsaka yon feet, feet. So, feet, tsaka feet. So, cancel. Pounds ang magiging unit. No? So, 6607 pounds. Next, to the right naman, yung sa right. Okay. So, consider natin itong HR. Okay. So, yung height na yon. And then, yung area to the right, yung projected area na nasa right, yung AR. Okay. So, HR yon. So, specific weight is 62.4 pounds per cubic feet. HCR, yung sa centroid, 1/2 of HR lang yun. No? And then, AR, okay, yung 7 times, yung 7 feet na yan, tapos yung HR. So, yun yung AR9 na hanap natin. Okay? So, next, ito yung ating data. So, it's obvious, no? Dahil itong triangle na to ay similar dito sa triangle na yan. Kasi, kung ito ay theta, theta. Ito ay 90 degrees, ito ay 90 degrees. Therefore, ano yung angle na to? 90 degrees minus theta. 90 degrees minus theta. O kapag ka yung corresponding angles ng bawat isa ay equal in measurement, we can therefore say that they are similar. No? Next, we have, so therefore, widen yan, no? Widen. Kanina, y ito. Therefore, ito, widen yan. So, increase in height, y. Decrease in height, y. Dito sa side na to, decrease in height. Dito sa side na to, left side, increase in height. So, this is, again, pareho din, 10 feet yon ito. So, yung ating length dito, 10 feet. Okay? So, therefore, 2.5 feet yan. So, y is 2.5 feet. No? So, kapareho lang makukuha natin. So, HR is 3 minus y. Diba? Kasi original is 3. Ito ay y. Yan ay y. Ito ay HR. So, ang HR ay total na 3 minus yung y para makuha yung HR. No? So, 0.5 feet. So, pwede mo nang i-substitute. 0.62.4, 0.5, 7.5. Makuha natin ay 54.60 pounds. Okay? Next. Given yon, show that the difference between those forces equals the unbalanced force necessary to accelerate the liquid mass. So, F equals to MA, unbalanced force. FR minus FL equals to F. So, yan ang isa-show down natin na yung difference between those forces, FR minus FL o kaya FL minus FR equals sa unbalanced force, yung F equals MA. No? Yung Newton's second law of motion, diba? Yung F equals MA, the law of acceleration. So, in that case, binigyan ko siya ng absolute value. Ibig sabihin niya, kasi yung difference pwedeng positive, pwedeng negative. So, kunin natin absolute value para maging positive. No? So, MA. So, we have mass. Ang density kasi ay mass over volume. No? Yung mass kasi ng water dito ay hindi sinabi. So, we can have this formula now. Density volume equals to the mass. No? Ayan. Times the acceleration. Ang assumed temperature ng density ay 4 degrees Celsius. No? Times the volume of water in the problem. Volume of water. Times the acceleration. So, FR is 54.6. Ito. FL, 6607. Density of water, 1.94. Bakit 1.94? Kasi ang mga given mo ay naka-fit. Diba? Naka-fit. So, 1.94 yung akong gamitin na density. Slug per cubic foot. Cubic foot. No? 1.94 slug per cubic foot. Naturo ko dati yan. And then, volume of water. What's the volume of water? O, yung original, eto, 3. Tapos, length times width times height. Kasi rectangular parallelepiped yan. 3 times 7 times 20. Ito. Yung area of the base. Area of the base, 20 times 3. Area of the base. Times length, 7. BL, 20 times 3, 60 times 7. So, yun yung ating liquid volume of liquid, no? Volume of water. And then A is 8.05 feet per second squared. Ito. So, therefore, 6,552 pounds. Approximately equal to 6,559 pounds. Actually, dapat equal yan. Pero kasi, may mga minsan sa pag-round off, kaya nagkakaiba. Actually, hindi naman talaga 1.94 lang yan. That is 1.937, etc. So, syempre, ito yung usual na ginagamit. Kaya hindi sila sakto. Okay? Pero saktong-sakto yan kapag hindi tayo nagra-round off at sakto din yung mga value. Let's say, sakto din yung kinuha nating density. No? Hindi lang 1.94. Lahat ng decimal niya, consider natin. At dun sa computation natin para sa pagkuha ng 54.6607, may mga ni-round off din natin yan. So, kaya hindi sila exactly equal. No? Pero we can therefore say na approximately equal na sila. No? Dito. So, yan. QED, sabihin yan, yan ang abbreviation ng Quod-erat Demonstradum. Okay? This is a Latin phrase, Quod-erat Demonstradum. Parang Laus Deo Semper, praise God always. Quod-erat Demonstradum. Ano sabihin niya? What is to be shown? Sabihin niya. This is to be shown na yung left side ay equals sa right side. No? Yung difference between those forces equals yung balance force necessary to accelerate the liquid mass. Okay? So that ends problem 1. So problem 2. If the tank from problem 1 is completely filled with water and accelerated in the direction of its length at the rate of 5 feet per second squared, how many gallons of water are spilled? Okay, ito yung ating liquid water. Okay? Nung na-accelerate siya, may natapon. Ito na lang ang natira. Ito na lang natira. Originally, ganyan siya. Natapon yung iba. No? So, syempre, yung tubig na iba ay matatapon pag na-accelerate. No? So, ilang galon ng tubig yung nawala? So, consider natin. So, ito yung liquid na nawala. Ito. Liquid spilled. No? Na-spill out. No? So, in this case, consider natin ito na Z. Yung height na to. Kapareho din dito, Z. Okay? Para sa pagkuha ng volume na spill, na consider natin tong side na to ay Z, na hindi natin alam yung value. So, ang volume spilled natin ay itong area of the base times the length. BL. Ang base natin ay triangle, right triangle. So, anong area ng triangle? 1/2 base times height. 1/2, 20 yung base, height yung z. 1/2 base times height. 1/2, 20z. Alam nyo naman yun, right? And then, yung length is 7 feet. No. Yung length ay 7 feet. Okay? So, paano natin malalaman yung z? O consider natin itong angle na to. Theta. Okay? So, kung yun ay theta, ito din ay theta. Alternating angles sila, right? They are alternating angles. So, kung ganon, kung yun ay theta, ito rin ay theta. Okay? Ano ang tangent theta dito? Opposite over adjacent. Opposite natin ay z. Adjacent natin ay 20. No? Tangent theta is opposite over adjacent. Z over 20. Recall natin yung tangent theta is the formula A over G na na-derive natin. So, therefore, Z over 20 equals to A over G. So, Z is 20 times acceleration ay 5 feet per second squared. Ang G natin ay 32.2 feet per second squared. Okay? So, ang Z natin ay 3.106 feet. No? So, yan ay 3.106 feet. Therefore, this is 1/2 of 20 times 3.106 times 7. So, sabihin, yung natapon ay 217.4 cubic feet. At take note, for every 1 cubic foot, that is 7.48 gallons. Okay, 1 cubic foot is 7.48 gallons. That will give us an answer of 1,626 gallons. So, yan yung na-spilled out na liquid, na water. Okay. How many gallons of water are spilled? So, there are 1,626 gallons of water that are spilled. Alright, that ends my discussion for today.